Hey guys, now we're in section 8.4, matrix algebra. We're going to look at ways to multiply matrices, combine matrices together by adding, subtracting them. So first of all, just notice that if you multiply by a scalar referring just to a number, not a matrix, you multiply every single element of the matrix by the scalar. So for this example here, you would just literally multiply every single cell of the matrix by -2. So we would get -8, 12, -2, -10, -14, and -4. It does not change the size of the matrix in any way. If you are going to add or subtract matrices, first of all, the matrices need to be the same size. And then you just add and subtract the corresponding cells. So for this example, what you can do is multiply by the scalars first and then combine the matrices together. So I'm going to first multiply the first matrix by 6 and the second one by -4. So this will not change the size of the matrices. So 18, -42, 0, 48, 6, 54. Now I could multiply by 4 and keep it as subtraction, or I could multiply it by -4 and change it to addition. I think I'll go the second route just to keep it as a plus, a little bit easier to work with. So we'll have 12, -12, -40, -20, 8, -4. So now when we add these together, we just add together the corresponding cells. So I have 18 plus 12 in the first row, first column position. So that will be 30. And then I have -42 plus -12 in the second row, first column position. So that will be -54. So you keep going the same path. So 0 plus -40 is -40. 48 plus -20 is 28. 6 plus 8 is 14. And 54 plus -4 is 50. So we started with 2 by 3 matrices, and we ended up with a 2 by 3 matrix. Next, we're going to take a look at matrix multiplication. So here I have a 3 by 3 matrix times a 3 by 2 matrix. So I like to write them offset from each other, kind of diagonal from each other, because it's more easy to see the size of your product. So I'm going to write my 3 by 3 matrix here. I'm going to write my 3 by 2 matrix up here. So kind of built in, I can see the size of the product. The product fits exactly right here. And it looks like a 3 by 2 matrix. So the way that you do this is to populate this first spot here. I use this entire row and this entire column. So I'm going to multiply 4 times 2 plus -2 times 4 plus 3 times -3. That will give me -9. Okay? Now, to get these next two spots here, I'm going to use the same column I circled here, but we'll just move down the rows. So for this next one, this one right here, I have to use this row. So I'll have 0 times 2 plus 1 times 4 plus 2 times -3. So 0 plus 4 is 4, minus 6, so -2. Okay, so we keep going. You don't have to write out your work. You won't be able to do it in your head. So for this last spot down here, I'm going to have -1 times 2 is -2, plus 0 times 4, -2, plus -1 times 3, -5. Now when I get to the next column, say right here, I move on to using this column and then all 3 rows once again. So 6 times 4 is 24. 24 plus 0 is 0. Is 24. Plus 15 is 39. Okay, moving on down. 6 times 0 is 0. 0 plus 0 is 0. 0 plus 10 is 10. And then we have negative 6 plus 0, negative 6 plus 5, negative 1. Okay, keep going down. Next here we have the identity matrix. The identity matrix is a square matrix that looks just like this. It's called the identity because if you multiply a square matrix by the identity, you get itself back. The way to find the identity matrix is to create an augmented matrix and then get into reduced row echelon form. So I'm going to show you how to do that for a 3 by 3 matrix. So I named this matrix matrix A, so we're going to find A inverse. So first we write out our augmented matrix. So you write this matrix here. And then you write the identity matrix over here. So we'll have 1s in the diagonal, 0s elsewhere. And the goal is to use row operations to get this left-hand side to be the identity matrix. Then whatever is left over on the right will be A inverse. So we've done reduced row echelon form to solve a system. Row operations to solve a system. So we do a very similar thing here. We're just working on the left side, and whatever happens on the right happens. So I think I will start off by using this 1 here to take out this negative 1 and this 1. So I'm going to leave row 1 alone, and I'm going to do row 1 plus row 2 down here. And I think I will do negative row 1 plus row 3 down here. Okay, so row 1 is staying the same. So to write out our two new rows, so row 1 plus row 2 will give me 0, 2, 5, 1, 1, 0. Negative row 1 plus row 3 will give me 0. Let's see, negative row 1 plus row 3. Negative 1, negative 2 plus 0, negative 2. Then negative 1, 0, and 1. All right, we did not change row 1, so you go ahead and write it out. It was 1, 0, 2, 1, 0, 0. Okay, this looks pretty good. I think what we can do now is, maybe you're seeing this already, use this negative 1 to take out the 2. So 2 times row 3 plus row 2. There's 2 zeros here, so those will not get screwed up by doing this. That's great. So let's go ahead and do that on our next step. I'll do 2 row 3 plus row 2, and I'll write that in the row 2 position. I will leave row 1 and 3 alone for now. Okay, so we're doing 2 row 3 plus our row 2. So this is 0. This is 0. That was the whole point. 2 times negative 2 is negative 4 plus 5 is 1. That's awesome. We're getting a 1. 2 times negative 1 is negative 2 plus 1 is negative 1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 0 is 2. Okay, and now I'll rewrite rows 1 and 3 exactly the same. 1, 0, 2, 1, 0, 0, 0, negative 1, negative 2, negative 1, 0, 1. Okay, so what was great about that last step is that we got a 1 right here. And we can use that 1 to take out this 2 and this negative 2. Because there are zeros elsewhere in the row, it won't mess up any of the other 1s or zeros that we already have. So let's go ahead and do these steps. So I'm going to do negative 2 times row 2 plus row 1. And I'm going to do 2 times row 2 plus row 3. Okay, so this is going to get us a lot of zeros, which is great. Okay, so what are we getting? Negative 2 times row 2 plus row 1. So that's going to be 1, 0, 0. Negative 2 times negative 1 is 2 plus 1 is 3. Negative 2 times 1 is negative 2 plus 0 is negative 2. Negative 2 times 2 is negative 4 plus 0 is negative 4. 2 times row 2 plus row 3. So 0, negative 1, 0. Negative 2 minus 1 is negative 3. 2 times 1 is 2 plus 0 is 2. 2 times 2 is 4 plus 1 is 5. Okay, and I will now copy down row 2. We didn't change it. 0, 0, 1, negative 1, 1, 2. Okay, we're super close to being done. It looks like row 2 needs to be moved down, and row 3 needs to be moved up, and also multiplied by negative 1. And I think once we do that, we will be finished. So let's write those steps out. Row 1 is perfect. So I'm going to take negative row 3 and move it to the row 2 spot. And I'm going to move row 2 down to the row 3 spot. And then we should be finished with this one. Okay, so negative row 3 will be 0, 1, 0, 3, negative 2, negative 5. Row 2, moving it down, 0, 0, 1, negative 1, 1, 2. And then we're recopying down row 1, 1, 0, 0, 3, negative 2, negative 4. Okay, so on the left-hand side, I'm seeing those 1s and 0s. It looks like the identity matrix. So that means we're done. And then what's left in the 3 by 3 on the right-hand side is A inverse. So let's go ahead and write it down. It asks us to find the inverse matrix, so our answer should be a 3 by 3 matrix. So we're making sure that we're actually answering the question. Okay, and there it is. So the next part of these notes is going to show us a way to use the inverse matrix to solve a system of equations. So let's say you had a system like this, where I underlined. You could make a matrix, a square matrix, out of the coefficients, a column matrix with the variables and the constants. And what this is showing us down here is a way to manipulate that to use A inverse to solve for x, this matrix here, which will give us the values of x and y. So the punchline is really the important part here. X will equal A inverse times B. So you need to find the inverse of A and then just multiply it by B, and that will actually solve the system of equations for you. So I'm going to show you how we can use that inverse that we found above to solve this 3 by 3 system here. So let's start by writing out what matrix A, X, and B would be for this system. So matrix A is just the coefficients. So this matrix will look familiar because we just worked with it above. So those are the X coefficients. Here's the Y coefficients. So 0. Here's the Z coefficients. So this is the same matrix that we found the inverse for above. Then the X matrix would be the unknowns. So here's what we're solving for. And then the matrix B is the constants. So if we multiply A inverse times B, we should be able to solve for X, Y, and Z. So luckily we already found A inverse. So let's write it down. We found it. It's the last thing we did. So A inverse was this matrix here. 3, 3, negative 1, negative 2, negative 2, 1, negative 4, negative 5, 2. So we found this on previous page, in case later you're wondering where that came from. Okay, so according to this above, X is equal to A inverse multiplied by B. So we're going to do that. We're going to take A inverse and multiply it by B. So here's A inverse. And here's B. So our product will be a 3 by 1 matrix, as it should be. And it will just be the values of X, Y, and Z. So we learned how to multiply matrices above. So I'm going to start with this row and this column to fill in this spot. So 3 times 6 is 18. 18 plus 10 is 28. 28 minus 24 is 4. Move on to the next row. 3 times 6 is 18. 18 plus 10 is 28. 28 minus 30 is negative 2. Now we're on the last row. 1 times 6 is negative 6. Plus negative 5 is negative 11. Plus 12 is 1. So what this has done for us is now we have matrix X. And it is equal to this matrix here, 4, negative 2, 1. So X is equal to 4, Y is equal to negative 2, and Z is equal